So let's do some compound probability, and that's when there's more than one event. So what is the probability of flipping 3 tails in a row? So we're going to try to calculate the probability of that. And so that's just when you go event 1, you just multiply them together. Event 1 times event 2 times event 3. So if you look at that, what is the probability of flipping 3 tails in a row? All right, so that's why there's 3 events. 1, 2, 3, 3 tails, 3 events. And you're just going to do your wanted over total 3 times. So because it's the same thing, our event 1, 50% chance, 1 out of 2 times 1 out of 2 times 1 out of 2. And you're just going to go across when multiplying fractions. 1 times 1 times 1 is 1. And then 2 times 2 times 2 is 8. So there's 8 possible outcomes, and our probability of them being all tails is a 1 out of 8. So that's what compound probability is. Let's look at another example. What is the probability of rolling a number 2 on or less on a 6-sided dice 4 times in a row? All right. Probability of rolling a number 2 or less. This is why you got to read these questions, or less on a 6-sided dice 4 times in a row. So let's do this right here. We're going to go with our wanted. Over total. And so you also want to know how many events. There's 4. So we're going to multiply this 4 times, and it's the same event. Right? Because it's the same, and it's going to be a 2 or less, right? Read it, a number 2 or less on a 6-sided dice. So our wanted, we have 2 times that we could get a 2 or a 1, because 1 is less, and then there's 6 total outcomes. Or you could simplify that to a 1 out of third. Again, if you do it on a calculator, it's going to give you the same answer. So you can write it as 2/6 or 1/3, and then there's 4 times. So there's 4 events. So what we're going to do is we're going to multiply this times itself 4 times. So we got 1 out of 3 times 1 out of 3 times 1 out of 3. Right? So we got our 4 events. What is the probability of rolling a 2 or less on a 6-sided dice 4 times in a row? So we got our event 1 times event 2 times event 3 times event 4. And let's go ahead and go do this in Desmos for time's sake. So we got 1 out of 3 times 1 out of 3 times 1 out of 3 times 1 out of 3. And so if we want to get that to a percentage, just copy and paste that. And you can just write it 0.0123 times 100. So 1 out of 3 times 1 out of 3 times 1 out of 3 is going to give you that decimal, or a 1.23% chance. And I'm just going to show you that it's the same as doing, if you did 2 out of 6, it's going to give you the same answer. 2 out of 6 times 2 out of 6 times 2 out of 6 times 2 out of 6. So see, it's the same answer, so it doesn't really matter, whatever you prefer. They say to simplify, but again, if it's going to give you the same answer, it doesn't really matter. So let's take a look at some other ones. What is the probability of rolling a pair of dice and getting 2 sevens? So again, if you have 2 dice, let's say you got the white and the red, this is all the possible. This is a frequency table of what you could get. And if that's broken up here, so there's a 1 in 36 to roll a 2, 2 in 36 to roll a 3. So again, a 2, you can only have a 1 and a 1. A 12, you can only have a 6 and a 6. So if you look at these outcomes, it gets, there's more, the more you go, and this is a symmetrical table, right? So a 4 or a 3 is the same probability as an 11. A 10 is the same probability as a 4. A 5 is the same probability as a 9. An 8 is the same probability as a 6. And then the one that's most probable is going to be a 7 because it has the most possible combinations that you could get a 7 with. So that is what a frequency table looks like. And again, you have a 6 in 36 chance to roll a 7. And if you ever go to casinos, that's why 7 is such a big number there, because 7 is the one that is the most probable to happen. So the probability of rolling 2 7s, again, you can do it by looking at the frequency table, or you can just do it by your wanted over total. And we have 2 events here, 2 times 2 7s, and that's going to be a 1 out of 6 times, or sorry, there's the, it's not the, it's because we could roll a 6 and a 1, a 2 and a 5, a 3 and a 4, and then you could flip the other dice, a 3 and a 4, 2 and a 5, or a 1 and a 6. So again, you count that up, we got 1, 2, 3, 4, 5, 6 out of 36 chance to roll a 7, or you could make that a 1 in 6 chance. So either way, what about this one? What is the probability of rolling 15 non-reds in a row in roulette? All right, so roulette, see, you have your ball here, and if you spin it, what does it land on? So that's what roulette is, and this is how the probabilities are broken down here. So there's 18 reds on the board, there's 18 blacks on the board, and there's 2 greens on the board. So what is the probability of rolling 15 non-reds in a row? All right, so non-red would be black or green, right? And then our total possible would be including all the possible spaces it could land on. So that would be black, red, or green. And yeah, very good, Jonas. So let's now figure this out. So we got black, green, or red. So black or green, there's 18 blacks plus 2 greens. So we have 18 plus 2, and then there's 38, 18 plus 18 plus 2. So there's 38 possible. And so you have a 20 in 38 chance of getting 50 on just one roll. So if we just had one roll or one spin, you have a 20 in 38 chance of getting a non-red. So let's go ahead to Desmos and let's look at that. So you have, in one spin, you have 20 divided by 38. So you have about a 52% chance of getting a non-red. And so, but if we want 15 events, this is where it gets a little tricky. So that means we're going to have to times this by itself by 15 times. So we're going to times that by itself 15 times. However, I'm going to show you a little trick here, that instead of writing this out 15 times, what you can do is you can put it to an exponent of 15, and it will give you that calculation. So if you give it an exponent of 15, that's the same as if you wrote it out times itself 15 times. So it's a nice little shortcut. And so let's see what percentage that gives us. So that's a 0.0065 chance. And if we want to see how many times that is, So that'd be a 1 in 153 chances of getting 15 non-reds in a row. So very small chance, 0.065% chance, or 0.00065% chance. So it's very unlikely that you would go to a casino and get 15 non-reds in a row. Let's look at a few other probabilities. So have you ever seen the NCAA tournament bracket? So this is based off the assumption that each game is a 50% chance. So you have first round, second round, third round, fourth round, fifth round, and then the title game. So there's 63 total games if you're to add these up. So Warren Buffett once said that he would give, if somebody ever picked Warren Buffett's a billionaire, if somebody ever picked every single game correctly, he would give them $1 billion. But that's a very safe bet on his part because it's almost impossible. So if you would have to, let's say you're going off the assumption that you have a 50% chance of getting every game right. So the probability of getting one game right would be a 1 in 2, so 50% chance. But remember, there's 63 total games. So you would have to put that to an exponent of 63. So that is 1.08 times 10 to the negative 19, which is like, that means your percentage chance would be, you'd have that. What this means is it's too small of a number to give an actual number. So that means there's essentially a decimal with 0.0000. That means there's 19 zeros here before you get to this 1. So the calculators only go up to so many digits here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that is your chances of getting every single game correct. All right, we're getting close to finishing. So let's look at a few more things here. One thing on your test, there's going to be win probability charts. And so this is based off the data of past games that have been played. So it takes all the data of games where teams with similar records have a similar score, and it's just calculating what the chances are that a team is winning. So if you're just looking at this game, what's happening is Atlanta probably starts off as a small favorite. Then they're ahead in the first quarter, and then think about halftime is going to be halfway. They're staying ahead, so Atlanta's ahead most of the game, loses the lead but gets it back, and now Washington takes a big lead in the second half, so Washington's ahead. Atlanta starts to come back, so this is a back and forth game, and then closer it gets to the end, Atlanta takes the lead back, and then like 100. This means 100% chance of winning for each team. So that's what that looks like. This one, it would be an example of a blowout win. So Philadelphia versus Minnesota. So the first half looks like it's kind of a close game. Minnesota ends up taking a big lead, or not a big lead, a small lead, and then they get here. And then something happens in the second half, and Philadelphia just right here, it's like their chances of winning are like 90%. So that means something happened. They have a huge lead, and then they just end up coasting. And then this would be an example of a choke job. Okay, I'll post the video as well. So this would be an example of a choke job. Las Vegas is up the whole game, and then something happens in the last minute, and they end up losing, and the Rams end up winning. So this is what a choke would look like on a win probability chart. So that is all I have for you today. I will go ahead and post this video so you can rewatch it if you get stuck. We'll see how we do on the first few tests. If we struggle, we'll definitely go over this more.
Thank you, Mr. Saline, for real. Have a good day.
Hey, you too, Noah. Have a good one.
Yep. Peace out.